Hello everyone, let's talk about another easy problem on Leetcode today. Relative ranks, Leetcode 506. It says that we are given an integer array score of size n, where score I represents the score of the ith athlete in the competition, and all scores are guaranteed to be unique. So based on that, we have to rank the athletes. By placing, like for example, first the score with the highest score will get the gold medal. The athlete with the second highest score will get silver medal. The athlete with third highest score will get bronze. And finally, rest of the athletes will get the rank from 4 to the end of the array. So for example, now they have given this examples below. So first example is when we have uh, already, I think, sorted array in a way where fifth employee gets like the athlete with score the zeroth athlete with score 5 gets gold medal. Like first athlete gets what you say with score 4 gets silver medal, and so on. I think second example is more interesting. There we see that the zeroth athlete gets a gold medal. Then we see that the second last athlete with score 9 gets a silver medal. Third last athlete with the score 8 gets the bronze medal, and then rest of the athletes get the what you say remaining medals, not medals, remaining ranks. Now let's now jump into the solution space. One thing we can definitely use is sorting, but if we sort the array, then we will lose the indices, right? So let's look at the example. What I mean by this is, so suppose we have the first array which is already sorted, right? So in this case, I think it's not a problem, but let's look at the another solution, or the another array. Here the array is not sorted. So if we sort it by 10, say in the descending order, then we will get 10, 9, 8, 4, 3, right? So now this is a problem, because now when we have to return the answer, we have to return it in the order of, say, first should be a gold medal, then similarly like 9, the value with 9 should be what you say silver medal, right? And things like those. So so that means we need to also store the indices somewhere, and then sort the array. So one approach can be that we can duplicate this array, sort it out, and then create a hash map between the sorted value and the indices in the array. So we can just loop on the array, the original array again, and when we find the value in the sorted value, we will just store the index for that. So this is one approach. Another approach can be that in Java, for example, we can use a comparator interface and create a pair array. So pair will be like will be a pair of value and the index, right? So for example, I'll again take the second example, but suppose we create a pair of values which will be like, say, 10, and the index is 0. Then we can create 3, and index is 1. Then we get the value 8 and index for it is 2. Similarly, we will get the value 9 and index for it is 4. And sorry, index for it is 3, right? Index is linearly increasing. And then we get 4, and the value and the index for it is also 4. So now what we can do is, like, we can sort these values by the value that we have. So that will return this, like, this is the first index in the sorted array, then this will be second, this will be third, right? And this will be fourth, and this will be fifth, right? Now what we can do is, like, with this sorted array, of course, when we sort it, I think it will look like, okay, 10, 0, 9, 3, 8, 2, and finally we will have uh, 8, 2, right? And then we will have 4, 4, and finally we will have 3, 1, right? So once this array is sorted, now we know, okay, this is the first value. So it is at 0th index. So in our answer array, we will set answer of 0 is equal to gold medal, right? Similarly, answer of 1, then we go to 9, and answer of 9 is index 3, right? So we will say answer of 3 is equal to silver medal, right? We can also see the silver medal here. That's at index 3. So this is one approach. Now, when it comes to time complexity here, again, the time complexity is O of n log n because we are sorting the array. And then we can also use what you call um, how is it like then we are also storing this in the new pair array, right? So that will also take time, space complexity of O of n. Now let's jump into the code part. So first thing we can do is we can create a pair array, right? Where it will contain, so each array will contain like the value and the corresponding index. So let's call it pair because score is also, yeah, singular. So let's create the variable for score length just to reuse it later rather than writing it again and again. Now what we will do is like we will start looping onto the score array, right? And we will say pair I 0 equal to what you say score I, that is the value we were talking about, and pair I1 should be equal to I. That's it. And now what we can do is um, we will sort the array in Java using comparator. So we can, what we can do, like I told earlier, like we can either sort it in the ascending or descending order, but I think maybe choosing the descending order is better. So what we can say is like if we pass A and B, we can sort it based on B0 minus A0. Yeah. Oh, by the way, I'm not sorting the score array, but the pair array. Yeah. So because we need to keep the order of indexes or indices correctly. So now that we have sorted this array in the descending order, or it shouldn't be, yeah, this should be good. Yeah. So now what we will do is like we will, and why I'm using index 0 because I want to sort it based on the value. And from this, once it's sorted, I can actually just get the index and start filling in the answer array. So let's create the answer array. Right, this should do it. And now the next step should be for equal to 0, I less than n, I plus plus. Yeah, now I'm actually looping on the pair array, right? So what I will do is like if yeah, so now let's think about it, how we can populate the array. So what we can do is like if I is equal to 0, that means we are putting in the gold medal, right? So we will say answer of pair I 1 because we need the index, right? um, I can actually also keep it out here. So index is equal to pair I1, right? And now if I is equal to 1, what we will be doing is like we will be saying, okay, answer of IDX is equal to gold medal. Uh, if I is equal to 1, we have to do the same thing for silver medal. And if I is equal to 2, we have to do the same thing for the bronze medal, right? Actually, I can, yeah, do them in a else kind of a thing, because then it's right. And if like in the final loop, what we can do is we can just say answer of idx is equal to idx plus 1. So if you remember, we talked about it that array is 0 index. So yeah, so I think in rest of the cases we don't have to worry about anything, and once we have done it, we will just return the answer. And let's try it out if this works. Oh, there's a compilation issue. Ah, okay, because yeah, I have to convert it to string. I hope this does it. So now there is a problem that, okay, so I am expect, okay, because my condition is same, so sorry for that. Yeah, so copy paste error, and now I think it should be good to go. So it says gold. Okay, I think there is some, yeah, I think I found the issue. It's a typo again. Sorry, guys. I think my brain is not fresh. I should be using I plus 1, right? Rather than what you say, instead of just IDX, because IDX is coming from the pair array and not in the actual rank thing, which should be coming from iterator I. So now let's submit this code. Yeah, and also I don't think I should be using, I mean, I can stop. I don't have to use what you say, um, toString method for that. I can just also do this. Let's run the code again. Hope should be fine. Yeah, and let's submit the code. Coolio, I think. Now let's jump into the priority queue solution. Yes, another thing that we can do is like we can use something called Max Heap for this problem. So the idea is that when we store the values in the heap, they should be what you say. They should be actually we'll be literally storing the index, but how we will be building this heap will be based on the values in the score array. So let's look at the example. So suppose we store the value 5 at the top of the heap, right? So but the value we'll be storing is the index 0, sorry, not the 5, but yeah, but it will be stored based on the 5. Then we add 4 to the heap, and 4 is actually smaller than 5, so it's all good. So we will add 4 here, but we will be storing the index that will be 1, but the value will be based on 4. Similarly, we will be adding 3 to the heap now, or index of the 3 to the heap now, which will be 2, but the value will be based on 3. Now we will then we will add now 2 to the heap, but the index will be 4 and the value will be 2. And finally, what we stored in the heap is 1, or like index will be 4. Sorry, this should be 3, yeah, not 4. Yeah, this should be 3 and 4, and the value will be 1 here. So now when we do the poll operation, we remove the top of the heap, which will be 5, and based on 5, but we will not get this value, but we will get this index 0. And once we have this index 0, we can say that, okay, for index 0, we get a gold medal, because that's the first value we removed from the heap. Now we put the node 4 to the top of the heap, based on the value 4 and index 1, but then we do the sifting operator, or sift up operation and whichever is the maximum of two children, which in this case four or two, will actually go up, and but the index for that is 1, and now we will assign the silver medal for value of 4 because we are doing it based on the value of 4. But I think this will become more clearer. Sorry if I was not properly explaining it. I'll try to do this better in next time, but that's the basic idea here. So now let's jump into the code part. So we can keep this part the same, but we can start storing the value in the priority queue. In Java, I think priority queue is used as a can be used as a max heap. Only difference is I think max heap in general have some kind of a limit. In priority queue, we don't have any particular storage limit, but we can somehow mimic it while adding or removing the elements from this queue based on the size parameter or attribute or function actually. So let's do this. We create a new priority queue, and it takes argument as comparator. So what we can do is we can pass on again the same thing, score B minus score A. So this way we don't have to create any pair array. And now what we have to do is, like, once we have done this, we can just start adding the values into it, or not the values, the indices into the priority queue, right? Right, and once this is done, now we can say that okay, int I equal to 1, and now we can start looping if like while priority queue is not empty, we can just continue this operation. So the first so I mean the first value we will get will be at the top of the heap, right? That will be the maximum element. We have to also create the answer array. And now we can say if I is equal to 1, that means yeah, so if I is equal to 1, we will just add answer of, first we have to get the index as well, so int idx, right, and answer of idx will be equal to gold medal, else if I equal to 2, I think I should have kept some part of the code from the previous solution, but I think now it's okay, it's too late for that. So silver medal. Similarly, if I equal to 3, it will be bronze medal, else right, it will complain, so I can do again the same thing. Uh, and at the end of the loop, we will start what is incrementing I, and eventually I will be equal to n, and at that point we will just return, and that will be our answer. Let's try this out. Awesome. So let's submit the code. Um, I hope this was useful, guys. I think there's another approach. I think both the solutions that we discussed will take O of n log n time, because in the first solution we talked about sorting, and that takes O n log n anyways, and then we iterate again, which will take O of n time in terms of time complexity. Space complexity wise, we were using the pair array, which will take again a lot of like O of n space. Similarly, Yeah, in the priority queue solution, the time complexity is O of n log n, because when we create the priority queue, that takes O of n time, but then removing or polling the value from the priority key takes O of log n time, and we had n elements, so it will take O of n log n time. Another noticeable approach which I didn't try it out but should be doable, which reduces the time complexity by to maybe O of n, is using counting sort or radix sort, because that makes integer sorting pretty fast. But I didn't want it to complicate the solution a lot and just wanted to share these approaches. I hope these solutions were useful. If you like, please like and subscribe, and also please see the code links in the description below. Thanks again. Have a nice day.